If there was something to get confused about in this section, again, it'll be all the individual properties that go with each individual quadrilateral. A lot of our quadrilaterals are parallelograms. So anything that's true about a parallelogram is going to be true about some of the other ones that we deal with, like a rectangle, a square, and a rhombus. They're all special types of parallelograms. So anything that's true about a parallelogram will also be true for those things. Kites, however, don't have to be parallelograms, nor is a trapezoid. So those would have unique properties that are different. So first off, let's talk about what a parallelogram is. By definition, it is a quadrilateral with opposite sides parallel. It has to have four sides, and the opposite sides have to be parallel. In other words, segment AB must be parallel to DC because they're opposite sides. Segment AD is parallel to segment BC. Just as a refresher, what would this tell us about their slopes? If the lines are parallel, their slopes are the same. The slopes are equal. Okay? Whatever these two slopes are, their slopes have to be equal. Whatever these two slopes are, they have to be equal. When you're naming a parallelogram, you'd put the parallelogram type symbol here. And you would pick a point to start with and work either clockwise or counterclockwise. What I don't want to do is go from A to C. I don't want to go across the diagonal. So I'm going to start at A, and I'm just going to go all the way around going clockwise. Parallelogram A, B, C, D. And you would list it by all four of its points. Questions so far? Okay. Properties then of a parallelogram. These are the things where people they're going to forget pieces of this. All five of these are important. The first property really comes from the definition. And if it comes from the definition, what do we know from the definition about the opposite sides? Opposite sides are parallel. And I'm just going to put the parallel symbol. Opposite sides are also congruent. In other words, I know that segment AB, not only is it parallel to DC, it's congruent to DC. AD is going to be congruent to BC. And I'm just going to mark that in my picture that they're congruent. Opposite sides of a parallelogram are congruent. Opposite angles are also congruent. Angle DAB is congruent to angle BCD. They're opposite. They're across from each other. Likewise, angle ABC is going to be congruent to angle ADC. Again, they're opposite of each other. Opposite sides are both congruent and parallel. Opposite angles are congruent. Consecutive angles are supplementary. And I'm only going to list one pair here, but understand that if I went from 1 mark to 2 marks, these are consecutive. There would be 4 sets of consecutive angles that I could list. So I do know that the measure of angle DAB plus the measure of angle ABC would be equal to 180 degrees. And last but not least, diagonals bisect each other. Which means segment AE is going to be congruent to segment EC. And segment DE is going to be congruent to segment EB. Again, the first one, we really learn it from the definition. Opposite sides are parallel. AB is parallel to DC. AD is parallel to BC. Next property, opposite sides are also congruent. Segment AB, segment DC are going to be the same. Segment AD, segment BC are going to be the same. Opposite angles are going to be congruent. Angle DAB is going to be congruent to angle BCD. Angle ADC is going to be congruent to angle ABC. They're opposite angles. Consecutive angles will be supplementary. There would be 4 pairs of them. So I could go from like the A to the B to the C to the D, and the D to the A. There's 4 pairs of them. I've listed 1. They will add up to 180 degrees. The reason that this one's true is they're same side interior angles. Remember, 2 parallel lines cut by a transversal. If they're same side interior, they would add up to 180 degrees. All the others we could prove to be true by using congruent triangles. The diagonals will bisect each other. In other words, E is going to be the midpoint of AC. E is going to be the midpoint of DB. AE and EC are the same length. DE and EB are also the same length. Questions about the properties? Well, if you know the properties, then we should be able to apply them. They told us that in each one of these they are a parallelogram, By the way, the instructions got mixed around. This one should actually say find the value of the variable. In the next set, they should say find the numbered angles. Remember that opposite sides are congruent, so what can you tell me about 6x minus 6 and 3x plus 30? What can you tell me about these two? They're equal in measure, so I should be able to take 6x minus 6 and set it equal to 3x plus 30. Subtract 3x from both sides. I now have 3x minus 6 equals 30. Add 6 to both sides. I have 3x is equal to 36. So when I divide by 3, x is going to be 12. There's part of my answer. The next part, what can you tell me about 5y plus 2 and 4y plus 12? They're opposite sides, so they have to be equal to each other. 5y plus 2 must be equal to 4y plus 12. Subtracting 4y. Y plus 2 is equal to 12. And subtracting 2, y is equal to 10. Everybody okay with example 1? If I take a look at example 2, I'm now dealing with angles instead of sides. Which of these are going to be equal? Which are going to be equal? The ones that are consecutive or the ones that are opposite? So 126 and the 5x plus 5 must be equal. Well, let's go ahead and solve this for x then. Subtract 11. I now have 115 is equal to 5x. And divide by 5. X is going to be equal to, what is it, 23. What do I know about these two angles? These should add up to equal 180. So I'm going to take 6y plus 126 and set them equal to 180. I'm going to subtract the 126. I now have 6y is equal to, which means y is going to be 9. Everybody okay with the first two examples? Here we're dealing with diagonals. I know that diagonals bisect each other. So I know that 4y has got to be equal to 18. I also know that x plus 25 has got to be equal to 7x plus 1. Divide both sides by 4. Y is equal to 4.5 or 4.5. Subtract x. 25 is equal to 6x plus 1. Subtract 1. 6x is equal to 24. When I divide by 6, x is going to be equal to 4. Everybody okay with the first 3 examples? Questions? Okay. This one was supposed to be find the numbered angles. Some of these should be easy. What's the measure of angle 2? If this is 72, then angle 2 is also what? 72. How would I find the measure of angle 1? 180 minus 72, or 108. And I know that it's got to be 180 minus 72 because when I add consecutive angles together, they've got to add up to equal 180 degrees. Example 5 is a little trickier. Where this 126 is, and where the 2 and the 48 are, all of that would have to add up to what? 180, because these are the consecutive angles. So I'd take the measure of angle 2 plus the 48 plus the 126, and it should be equal to 180 degrees. The measure of angle 2 plus then, is it 174 equals 180? And subtracting 174, the measure of angle 2 is 6. If the measure of angle 2 is 6, what's the measure of angle 1? It is also going to be 6 because they are alternate interior angles. The easiest angle to find in this one to me would be the measure of angle 2. What can you tell me about angle 2? (60) and angle 2 make a linear pair. So angle 2 had better be equal to 180 minus the 60. The measure of angle 2 then is 120 degrees. Which means over here would be 120, this one would be 60. How can I find angle 3 now? Anybody see it? How many degrees in a triangle? 180. So I know if I take the measure of angle 3 plus 60 plus 40, it's got to add up to what? 180. The measure of angle 3 is going to be 80 degrees. If angle 3 is 80 degrees, angle 1 is what? 80 degrees because they are alternate interior angles. Well, good. I'm going to skip those two examples. They do work out as systems of equations, but they're the same type of problem. If you have 3 or more parallel lines that are cut by 2 different transversals, if it creates congruent pieces in one of the sections, it will then create congruent pieces in the other section. If it creates congruent pieces on one of the transversals, it will create congruent pieces on a separate transversal. So this is a pretty simple example. Here I see that I have 3 parallel lines. I have 2 different transversals. They said DE was 5 and EF was 5, so I can see that these 2 pieces are congruent, which means whatever AB is, it has to be the same as BC. So how big is BC? BC is going to be 7. And how would I find AC? 7 plus 7, or 14. Well, good. Yep. It is Form G. You're going to do one. We're going to skip 7. This should say 8 through 24. You're going to skip number 7. 1 through 24, but skip 7. Right? 6.2 Form G.